Hello everyone, so today we are going to do Leetcode daily challenge and its name is Search a 2D Matrix 2. Its first version also we had it and now it's time for its second version. So in its second version, how the things are that here we are given with a matrix m cross n matrix, and then here what we are required to do is that here we are given with the integers in each row which are sorted from in ascending order from left to right, and then integers are also given in each column which is also sorted, and the sorting is also in ascending order and it is from top to bottom. So in all this context we know that all the integers here are in sorted manner and they are in ascending order. One is from left to right and other one is top to bottom. Because of this sorting only, we can refer that how we can find out a particular element in this whole matrix. So because of this sorting only, our work becomes much easier to do. Now, how they have figured out for this 5 is like they would have searched for 1, then 4, right? And that target is 5, right? So two things we can do. Either we can move ahead in this particular row or we can move to the second row and check for that particular column. Means either we can move in that row or we can move in that column. These are the two operations which we can do. Means either we can move towards the right or we can move towards the down for finding a particular element. And as all the elements are already sorted, so that's the scenario that we can use in this particular question. So now let's check for the constraint, that what are the constraints which are being given to us. So here m and n, m is simply the length, means that row count, and then n is simply the column count. That's the thing. And then n is here equal to or greater than 1. Means there could be multiple rows, but at least there would be one row. And regarding m, that is basically both are bounded, so there would be at least one column also. And for m here, which is given that m can at max go till 300 columns, or it could be equals to 300, but it can be even less than 300. That's the thing which is given here for the m. So basically a range is given for n and m. That is the scenario which is being given to us here. Now comes the part, the elements which are being stored in the matrix. The elements which are being stored in this matrix, they are from minus 10 raised to power 9 to 10 raised to power 9. That is the thing which which is given to us here. But that thing only matter to us for that concern about that what data type we would be required to use. But we will use only integers here. So that's why it's fine with this constraint. Means you don't need to have some other thing because we are not adding up anything or subtracting or multiplying or something. So that's why whatsoever value is being stored here, it is integer, and even it is not much of our concern, as we just need to figure out a particular number only. That's why it's alright with this constraint. Now comes the next part, that all integers in each row are sorted in ascending order and in columns are also. That is as per the question which was being given to us. Now the target is also in the range of the elements which are being there. So it's alright, means there is no invalid case in this scenario. So now let us start that how we can figure out for this particular question. So for that scenario, let us draw on this and explain you that how we can do that. So for this, we are required to figure out for this 5, right? So how we can find? We would be here at 1, right? Then we will check 1 is less than target. So we have two options. Either we can move towards the right side or we can move towards the down. That is the two scenario we can go ahead, right? So first we'll choose to move towards the right hand side and we will go towards the 4. So 4 is somehow closer to our target, right? So that's why we can again check for moving towards the next element, that is 7, right? But this element is somehow greater than our target, so we won't move towards the row, but we will move towards the downside. That is the scenario we will be doing here. And thus we reach our target 5, and then we will return our answer that we have reached our target 5. So this is the thing we would be doing. Means first we would be searching towards our row, and we will check out that till what number we are able to figure out that it is not greater than our particular target, right? If we found a particular number which is greater than our target, then we can directly eradicate to move towards that position, and we can directly move towards the down. And in that scenario, we will be able to either get a target, or we will get some number closer towards our target. That is the scenario here. So this is how we are required to think about coding this particular solution. Now, after this, let me walk you through the code that how we can code this particular solution. So for that scenario, let me show you the code that how we can code it. So here the thing is that first, that whatever row and column count are there, that I have taken, and then what I am doing is I am taking the top. I will be starting from the topmost element, right? So there would be the top element, and then right, that is the total number of columns minus 1, because it is 0 based indexing, right? So that's why we would be taking the column minus 1. Then if my row equals to 0, then I'll return false. Although this won't be a scenario here, because as per the constraint we are given that row is at least 1, so that's why we can even skip this particular case. Now comes the part that while top is less than row and row is greater than equal to 0, because what we would be right is greater than equal to 0, because what we would be doing is we will be simply decreasing our particular right, means decreasing our columns in that particular row. We would be starting from the top right, and we would be checking that if that particular element which is there, is it that element which is the right, which is the correct element as per the target or not. And why we are starting from the rightmost column is so that we are able to figure out that do we need to move towards down or not. So this is somehow a small trick which we have used here. Now comes the part that if our matrix of means if our that particular block is equals target, then we'll directly return true from that particular position only, that yes, we found the element, right? Else what we are required to do is we are required to do two parts. If our matrix of top right means our present block which is there, if it is greater than target, the way 7 was greater than target, right? So what we would be doing is we'll do right minus minus. In that scenario, we don't want to move ahead. We only are required to move towards the backward direction, that is toward our 4. That was the thing which we were doing at that moment. So that's why we'll do right minus minus at that position. Else we'll do top plus plus. The thing is that now we are able to check in our particular row. So that's why now we are required to move towards the second row. So that's why we would be doing top plus plus. So that is the thing we would be doing here. And that is how this particular question is all about. And then at the end we'll return false, and we'll return false in that scenario when in this particular while loop it is not able to reach at this particular point. Basically it is not able to figure out the target is there. Then at the end we will be returning false, because surely then there won't be that element. So that's why we would be returning false. So this is all about this particular question. Now comes the part of time complexity. The thing which we are doing is, because of this loop, we are able to figure out in a particular row how many columns we are able to traverse, and that's why we are able to figure out the answer, right? We are using a single loop only, in which our condition is in that manner, so that its time complexity becomes m plus n. That is, we are able to traverse our whole matrix, means go one by one in each row. But the thing is that it is not the scenario that in each row we are then checking for all the columns, right? We are just checking for few of the columns there, and in that scenario we are able to figure out our answer. So that's why a time complexity is simply order of m plus n, not 1, y would be 1, where m is the number of rows and n would be the columns, and space complexity is simply order of m, or not m, instead it would be order of 1 only, because we are not using any auxiliary space, we are just using our given input, this particular input matrix only for our particular solution. So this was all for this particular question. If you have any doubts, you could simply comment that down, and any question, anything, you could simply write that down in that comment section. I'll take and answer all that. And yeah, if it was helpful to you, then please do like and subscribe and even share with all others. So thank you.